We are given this quadratic equation. We know that this is a quadratic equation because if we expand this expression and simplify, we'll get the expression ax squared plus bx plus c. The highest power in this polynomial is x squared, so we know that this is a quadratic equation. A quadratic equation will have a graph of this shape, and we know this is a smiling face because the coefficient of x squared from this expression here is positive. We are asked to explain why the coordinate x equal to 3 over 2, y equal to -4 will give us the lowest point on the curve. Now the lowest point means the lowest y value of this graph is really -4. The minimum y value of this graph is -4. That means this y coordinate here is the minimum y value, is the lowest y value this curve can go. Let's go back to this expression. We know that the y value here depends on this 2x minus 3 square and this constant -4. Okay, this is a constant, that means it will not change the value no matter how the x changes. This expression here will be either 0 or positive values only. This expression will have no chance to give us a negative value because of the square here. Any x value here, after we square it, it will be a positive value, and the lowest value this expression can give is really 0. And because we want to find the minimum y, we want this to be as low as possible, and again the lowest value is 0. Therefore, to have a minimum y value, we set this to be 0, and the minimum y value will occur at -4. This explanation is written down in words here. Minimum y will occur when 2x minus 3 squared equal to 0. If we were to solve this expression, we will get the value of x equal to 3 over 2. That means when x equal to 3 over 2, it will give us the minimum y. And this minimum y will be at -4. Okay, remember, when this is a 0, y will be equal to -4. This will be the lowest value of y, the minimum y. Therefore, lowest point is at x equal to 3 over 2 and y equal to -4. For question 12 part 2, we are asked to find the point at which the curve intersects the x-axis. And we know that when the curve cut the x-axis, we'll set y to be 0. So when y is 0, we'll have this equation. To solve the equation, I need to bring the square root to this side. Don't forget, for a square root, there will be a plus and negative value. So 2x minus 3 will be a positive 2, or 2x minus 3 will be a negative 2. So x will be 5 over 2, or x will be equal to half. So the x coordinate here will be half. The x coordinate here will be 5 over 2. In conclusion, the coordinate where the curve cut the x-axis will be 5 over 2, 0, and half 0. In the third part of the question, we are asked to sketch the graph y equal to the absolute value of 2x minus 3 squared minus 4. Okay, notice there is an absolute value here. Now, before we sketch this graph, let's gather what are the information we have for this graph here without the absolute values. From the previous question, we know that the lowest point of this graph here is 3 over 2, -4. And the graph cut the x-axis at half 0, 5 over 2, 0. We're going to sketch this graph first. Then from this graph, we're going to get this graph here. The lowest point is 3 over 2, -4. 3 over 2 will be here. And cut at half 0. 5 over 2, 0. We should also find a point where the curve cut the y-axis. Cut y-axis x equal to 0. So we substitute x equal to 0 to the equation. We will get a value of 5. Okay, so 2, 4, 6 here, 5 will be here. So let's join the points together. This is still not the required graph. We are supposed to sketch the graph with an absolute sign. To get the absolute value, what we do is the negative y value of the graph, we are going to reflect on the x-axis. Because an absolute of a negative value will be a positive values. And absolute of the positive value will remain unchanged. So this positive value of y remain unchanged. This positive value of y remain unchanged. The negative part will become positive. And we do that by doing a reflection on the x-axis. So negative 4 after the reflection will be a positive 4. Okay, so we join the points together. So this graph, the one in purple, will give us the graph y equal to 2x minus 3 squared minus 4 with an absolute sign. So since this is not the actual graph, we should put this graph as dotted line. Now in part 4a of the question, we are supposed to state the number of solution of this equation. We know that this part here is actually our y expression, and we have the graph of the y here. So we can replace this expression here by y. So y will be equal to 7. So what we need to do is we are going to draw the line y equal to 7. The line y equal to 7 is drawn here. So to find the number of solution for this equation, we just need to find the number of intersection point where the straight line and the curve meet. So because we have two intersection points, this equation, if we are going to solve it, it will have two solutions. So the answer for part 4a is 2. For part 4b, this value here will change to 3. That means you are going to draw the line y equal to 3. And the number of solution is 1, 2, 3, 4. So the answer for part 4b is 4. For part 4c, we are given this expression here. So we are going to move the 2 over so that we get the expression y equal to negative 2. We are going to draw the line y equal to negative 2 in this curve. For y equal to negative 2, as you can see, if we draw a line y equal to negative 2 here, there will be the curve and the y equal to negative 2 line does not intersect. So we can conclude that there will be 0 solution if we are going to solve this equation. That means when you solve this equation, we will not be able to find the real value of x. Okay, and we say there is no solution to this equation.